Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and OpsMX. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we've got an exciting webinar for you today. First, some housekeeping notes. Today's session is being recorded, so if you miss any of our session or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in using the Q&A tab, which can be found on the right side of your screen. That's also where you'll find the chat tab. That's where we want you to engage with one another, speak with us, let us know your thoughts throughout today's webinar. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is automating deployment verifications for Kubernetes applications. And I'm joined by Gopinath Rebala, CTO at OpsMX, and Mark Levy, Senior Director of Product Marketing at OpsMX. Mark and Gopi, thank you both so much for being here with us. Mark, do you want to take it from here?
All right. Hey, thank you, Cody, and welcome everybody. Really appreciate your time today. Happy summer solstice. So it's hopefully you're going to, at least in the Northern Hemisphere, if you're here, you're going to get outside. So just a quick overview for those of you who are not familiar with OpsMX. OpsMX is a continuous delivery platform provider. The platform is designed to safely and securely increase delivery speed without human intervention. OpsMX Intelligent Software Delivery Platform is an open, intelligent, and automated CD solution that provides deep end-to-end insights and control over the software delivery process. The solution is available as a continuous delivery as a service or as an on-prem solution. And as you can see by the logos at the bottom of the slide, OpsMX is trusted by leading enterprises worldwide, enabling them to ship better software faster. Now, one of our major missions is solving deployment complexity. Deployments are getting more complex as our customers transition to multi-cloud or cloud-first strategies. And as this transition happens, an increasing number of microservices are being developed and deployed using tools like Kubernetes. That's why we're here. With all this complexity, it's critical to make deployments simple by removing scripting and supporting automatic rollbacks, safe and easy with out-of-the-box deployment strategies like Canary and Blue-Green, and scalable. But as the velocity of the software delivery increases, it becomes more difficult for security, compliance, and verification to keep up without getting in the way. As more DevOps practices are automated, it becomes harder to capture the data required to ensure governance concerns are met. So organizations need an automated way to perform tasks like deployment verification throughout the entire software delivery process, so they can attest to the integrity of all assets and to the security of all running applications. So teams are currently leveraging CI/CD tools that they have at their disposal. However, verification of software deployments is still a manual, time-consuming process. DevOps teams spend many hours, as you probably are well acquainted with, diagnosing and troubleshooting issues or identifying the risk in build, test, and staging environments. Maintaining compliance with corporate regulatory policies also requires a significant amount of time. With all this time spent, it's no wonder that the verification of overall health of a software deployment and sharing best practices between teams frequently fails by the wayside. So what I want to do is just give you briefly some case study examples. I'm going to just provide the original problem state, but I encourage you to go to our website and review the entire case study to see the business outcome. The link is at the bottom of the slide. So the first one is a well-known destination site, millions of monthly viewers, a leader in its segment. You know, its goal was to move, of course, quickly and at a lower cost, and it was not happening. It was costing them over $1 million a year on deployment verifications. And the problem was through the analysis process for every deployment was time consuming because of the mountains of data generated. With hundreds of thousands of concurrent users, there was a tremendous amount of metrics and logs created. And as the team's frequency of updates increased, the severity of the problem grew until they were nearly at a breaking point. The next use case is a regional telecom leader wanted to reimagine the digital retail experience for their customers. And the DevOps team could not meet the demands of the business. Their deployment cycle times were weekly and they needed daily. Verification of new releases into production were carried out manually by collecting and analyzing data from multiple monitoring tools. And the process was, of course, repetitive and time-consuming, and any mistakes would mean troubles like production downtime or performance issues or low website engagement. And the final case study is a leading digital payment player in Africa who was instrumental in transforming Africa's payment landscape. Being in the finance industry, this provider has to strictly comply with regulations and standards, and it was challenging for their IT team to manually address policy checks and adhere to SDLC regulations set by their own compliance team. So they needed a solution that could streamline their entire software delivery process, eliminate excessive dependency on tribal knowledge with respect to adherence to compliance requirements, and handle scale. Now, what all three of these are about is about as they accelerate the velocity of their deployments and try and scale, intelligent automation is required. As enterprises have complex processes, such as approvals and governance and audit steps, frequently they're human intensive with very high costs. And so at speed and scale, automation, intelligent automation is critical. And so you have to ask the question, and we're going to answer that for you. How can we get from where we are, which is mostly manual, I'm thinking with pockets of intelligence, to fully automated? And so how do you automate? Of course, there are a lot of CI/CD tools out there that automate deployments, but the popularity and the rapid adoption of Kubernetes, Argo is probably one of the best choices. Argo is specifically developed for Kubernetes. The Argo project has several repositories that they're working on, but Argo CD is the GitOps way of handling deployments, meaning that Git repositories are the single source of truth, and that your Kubernetes cluster mirrors everything from those repositories. So with that introduction, I'd like to turn this over to my colleague and OpsMX CTO, Gopi Ribala. Gopi will now discuss how to implement intelligent delivery with Argo. Gopi, good morning.
Good morning, Mark. Thanks for everyone for joining us today. Mark has taken us through the motivation for doing automated verification for your deployments. So, like Mark said, there are multiple CI/CD tools that do the deployment. We also work with Spinnaker. It's a great tool for multi-cloud deployments. But today we'll focus mostly on Argo and the motivation for Argo rollouts, and then using automated analysis with that rollouts. Now, as you know, the Argo is a GitOps model. It essentially takes the Git as a single source of truth and applies it to a Kubernetes target. So what it does is only provides support by what Kubernetes supports, which is a deployment manifest, deployments to deploy into the target environment. The problem with that approach is that it only supports recreate or rolling update. Now, as you're going to production environments with zero downtime, you want to be able to reduce the blast radius of the changes that you're making. And what that means is you should be able to control what amount of traffic that comes to the new version, test it, make sure everything is going fine before rolling forward. So with the standard deployment model, the readiness probes are not sufficient for this kind of tests, right? Although they will make sure the pod is up and running, you still don't have the ability to verify your application is in good shape while you're rolling out. And so that is where the Argo Rollouts is introduced. So what Argo Rollouts provides is the ability to pause the sync between the Git and the target environment and completes the rollout with some strategies. And then once the rollout is complete, it sends it over back to Argo CD for keep the Git in sync with the target environment. Some of the things that are built in are the blue-green deployments and canary. We'll go through in a little bit more detail how they're achieved and how we can apply the automated analysis on top. One of the biggest issues is also this rollback. As the rollout is going through and at some point it fails, the verification of that new version fails, then it does have the ability to auto roll back. So, and let's look at some of these strategies and how they're pros and cons, if you will. So the first one is this blue-green rollout. As some of you may know, the blue-green is essentially bringing up the newer version in parallel to the existing version, make sure it's ready. You can do some tests on it, and then switch the production traffic completely onto the new version. So what this means is you're actually running two sets of software at the same time. So the drawback is that it's going to use a lot more resources than what you need in a production. In fact, double the resources that you need in the production before you switch onto it. But the advantage is you can fully test in terms of performance and scale before you're switching out. One of the reasons the blue-green was very useful in the cloud environments is that if you're in a VM kind of environment, it takes minutes to come up. Then if something goes wrong, the mean time to recovery is high if you have to bring back the older version. But with the blue-green approach, for you to roll back if a new version fails, it's simply a switch in the load balancer that takes you back to the original version. But in the container environment, where it takes only a few seconds for the containers to come up, this may not be as big a deal, but there are other considerations for using blue-green. We'll talk about that a little bit more. And the second one that's built-in support is the canary rollout. Here, there are multiple variations in the basic form that was originally supported by rollouts, and is this ability to bring up new instances of new versions instances, and then have them as part of the load balancer, so the traffic is sent to the new version as well. So in this case, in this example that you're seeing, there's only two instances of the V1 that's running. And when you bring up the V2 one instance, you're sending 1/3 of the traffic to the new one. So the blast radius is small. You can verify. Typically, if you have 10 instances or 20 instances of V1 that's running, the blast radius is much smaller, of course. You can verify the functionality before moving on or providing more traffic to the instance. So these are our built-in supports for the Argo rollouts, but typically these are the verification that are done, and it supports the manual pause between each of these steps. You can think of the first part that coming up as a step 1, and then 2 parts as step 2, and 3 parts as step 3, and you can have verification at each one of these steps. Now, there are slightly more advanced versions of these, which is experimental rollout and service mesh or ingress-based rollouts. The reason you want the experimental rollout is interesting is because, let's say you're rolling out a new version, and now we want to do automated analysis because at scale and at speed, the automated analysis is the best way to provide reliable and safe deployments. So in that case, if we simply bring up the new version of the pod, of doing a comparison with the machine learning or statistical becomes a little bit tricky, primarily because some of these applications, they can do caching in memory. And so they are a lot faster to respond as compared to a new version that is just deployed. It's still filling its cache based on the incoming requests. Or there may be daemon-based systems that are running in the background And the ones that are currently running may already have used certain amount of memory, and the new ones that are coming in are just filling it up. So the comparison between them does not become apples to apples, and it becomes harder for automated systems to identify different parameters to judge. So to simplify that process, one of the rollout mechanisms that's implemented is this experimental rollout. So what it does is when you're deploying a new version, you can set up an experiment which will bring up the current production version part along with the new version part simultaneously, giving them equal traffic. So these pods now have come up at the same time, and they have same characteristics, and they are using the same load on them, if you will. Then it's much easier to compare them, and then they're apples to apples sort of comparison. Our statistical or machine learning models work a lot better reliably in identifying if we are good to go with the rolling updates. So with this one, now you can still do the canary model. This, for example, if you have the service mesh ingress, you can bring up the new version instances independent of sending traffic to them. So you can see this service mesh model is a lot more flexible, but at the same time, it becomes very complex and you have to be very careful because if you bring up a smaller number of new version, like only bring up 1/10 of the instances of the new version and give the 50% of the traffic, you're bound to get into problems. So you have to be very careful in how you set it up in doing this more advanced canary rollout. But it gives you a lot of flexibility in how you transfer the traffic to them. And so typically we recommend slowly moving the traffic along with the number of instances coming up, but doing the experimental rollout first and then increasing the traffic is the way we recommend our customers to do it. Now, how is this set up? And now we know the Argo rollout supports the different rollout strategies, and blue, green, or canary, and the variations in the canary. But how is this set up, and how does this verification, automated verification, fit into the rollouts? So you say in your applications are running in the cloud, the Kubernetes applications. This cloud, it could be public cloud, EKS, GKE, EKS kind of environments, or Kubernetes on-prem, or Kubernetes that you brought up. You set up an Argo for deployments to those environments, and you have some kind of a monitoring setup. This monitoring can be APM level monitoring, or Prometheus, or and log monitoring for them. Right? So the way we think about monitoring is that the metrics represent the performance part of your application, and the logs represent your functional part of the application. In our automated analysis, we take both logs and metrics to analyze if there are any issues that should stop the rollout and roll it back. So what does that? How does that work, right? As any machine learning kind of systems or statistical systems, you observe, you learn from the data, and have a model that you apply on top of it. So as we said, there are two parts to it. One is the metric analysis, and then the other one is the log analysis. The verification model is going to look at all the metrics that are being generated and all the logs. And then based on those, it classifies some of these as errors or some of these as warnings and gives them certain score, and generates an overall score that allows the Argo rollout to determine if it can go forward with the rollout or it has to roll it back. The statistical analysis is applied mostly for the metrics. As the metrics, you can specify what type of metrics that you want to use in the analysis. And typically these are KPI level metrics. But as you know, in the continuous delivery, your application may have 10 to 20 microservices. And in the deployments, you could be deploying services that are not really exposed to the end user, but they're internal. So for these services, you may choose to use a different set of metrics than application level metrics, but you can have a combination of latency or throughput of the application and a performance metrics of the individual service, like memory utilization or CPU utilization. And you combine that with the logs that are being emanated by the services. So in these logs, the model will identify what new errors or warnings are coming in through some classification. Based on that, it gives a score. And then that score, that model is learned and it remembers over time. You can have someone giving manual judgment on top of it, saying, hey, this is really not an error, or it can be ignored, those kind of learnings that go with it, that becomes part of the model. And any future deployments will start using that. So the score generated by this model is what's used by rollouts, Argo rollouts, to determine whether it should roll back or continue with the roll forward. So you may be familiar with Argo rollouts. So essentially, the setup is that there is an analysis template. This template determines how the analysis is performed or what to use the analysis. There are few other types of analysis that you can apply. And so there are some, say, Kayenta is the Spinnaker community-based automated analysis system that does metrics-based analysis. You could use a purely Prometheus. This is becomes like a threshold-based system. You can select a subset of metrics that allow you to verify the thresholds. And if the threshold is passed, you want to roll back. If it's under the threshold, you support roll forward. This autopilot is the component that we support, which is the one that does advanced automated verification, which uses both metrics and logs. So in this picture, what you're seeing is the analysis run is based on the analysis template. Let's say we select autopilot as the analysis system that we want to use. When the Argo rollout kicks in, it's going to bring up the new version pods and then kicks off the analysis run that based on analysis template to call the autopilot saying there is a new rollout in progress, and then starts the analysis on the data. So how does the autopilot system know which metrics or which logs to look at for doing the analysis? So that is based on the rollout template. Here, if you see in the rollout template, you specify what kind of strategy you want to go with. Say in here, the strategy is canary strategy. And the steps are the one that where you would just specify how many steps you want it to go through. You may want to go from 0 to 100 of the new version in production in 4 steps, 5 steps, or 3 steps, or any number of steps that you want. So here, you're saying the canary, which is a type of an experiment. So as we discussed before, the experimental type is most suitable for the automated verification. It not only looks at thresholds for the overall application metrics like latency or throughput or errors, but it can also give much more detailed information on the performance of individual services that are deployed. So we go with the experiment. Here, what it's saying is there are 2 templates it should use to identify which one's the current production version, stable version, and then which is the new version, which is the canary version. And then the analysis represents what are the parameters that we pass in to analysis run to use for running the analysis. So the Argo supports something called pod template hash. For each one of the versions that we are deploying based on the spec, it creates a pod template hash and inserts that hash into those deployments or replica sets. And now, based on the monitoring data that is being generated by them, these becomes different dimensions in the monitoring data that's being sent. So any of the analysis systems like autopilot can pick up the data coming in with the specific pod template hash, and then identify which one is the canary version, which one is a stable version. And based on that, they can capture the data to do the analysis. Right. So essentially, each of these steps represents how much traffic is going to send and what kind of analysis is run. In here, the experiment that and the systems use this pod template hash to identify where the data is coming from and use that to analyze. So how does this analysis look? Right? Here is an example. The primary reason you want to do the analysis is to make this automated decision. But in case there is a failure, you want to go a little bit into detail. You want to first roll it back, of course, right? You want to recover from the failures and have a functioning system available to your end users. But then you also want to have the ability to fix the problem, identify where the issue is, and then bring the new version in as soon as possible. So for that, you need the additional data, more like a diagnostic data, and say why that has failed. In this case, it's showing you a success case. It gives you a complete report on what dimensions in terms of metrics and logs that he has worked on, and what the status of each one of these metrics are. So here is one case where the latency has a failure. It's very close to what the current production system is. But if you see there is one spike here, a single spike doesn't necessarily represent a problem because based on the model, you can take that as an anomaly and not fail simply because there's one spike in there. But the models are a little bit smarter in identifying the true difference between the current version and the new version that's coming in. So at this point, it identifies where the issue is and what kind of API calls that cause the issue. And for this specific version, what is the latencies that it is kicking in. So we can then use this in conjunction with the logs to identify exactly what has caused this issue. Right? So the simplest one are the configuration problems where you can immediately see there is latency coming in because of the failures in the log files and the latencies for a specific type of APIs that are causing the problems. But the harder ones are where you have intermittent problems like this. Then you have to look at both the metrics and logs to identify the problem. But the good thing is the Argo rollouts automatically will roll back the issue and lets you figure it out after the fact once your system is still running. Now, one of the common issues that we get into is as I deploy my new service in the rollout, my application is actually made up of more than one service. I have 10 services or 15 services. Now, there are dependent services that may be causing the issue, not just the one that I'm currently rolling out. So how can we analyze these multiple services and get a better view into where the error came from? So that's the analysis where when we specify the template, you could specify more than one service. Actually, if you see at the top, under the service, you have analysis pod, dashboard pod, and gate pod, prod. So these are all the different services that make up the application. You can analyze as you roll out service one. You can analyze service one, service two, service three, 4, 5 as a group and say, I am now deploying a new version, get me analysis across. And if any one of the individual service verifications fail, roll me back. So the reason this is useful is as you're looking at application metrics like the latency, throughput, you may not initially see a problem in those metrics, but in individual services that have dependencies may start seeing internal latencies or errors or retries that are happening because of rollout of the new version. You may find it much later in time. So this allows us to identify the problems before they happen and also gives you much faster diagnostic capability. So the other one is this contextual analysis. What this helps us do is when you say retry kind of errors are happening, the retries could be with the database, or it could be the external services, or any of those. If the errors are coming in and we identify these errors, we can analyze and then say, separate these errors out and say the specific error is because of the retry or connection to the database, and makes it much more easier for you to diagnose the problems. Okay? So what we've gone through is the reasons for using Argo Rollout along with Argo, and then how we can add automated analysis and the advantages of automated analysis using with the Argo Rollouts. So to recap, the rollouts you can use to not only analyze the application level, threshold level metrics, but also the performance or functional aspects to give a much better confidence in rolling out into production with zero downtime. Right? In these models, they learn over time. You can give them feedback and teach them about your application, and it characterizes them. So again, the confidence, or when you have multiple people doing the operations, DevOps model, developers could be looking at it, multiple operations, having these models built in and the annotation for these errors makes it a lot easier for new people also to recover from errors faster. And the contextual diagnosis is something that we just went through to identify which path you can use APM and enable APM for all of your services. You will get the trace for all of them. But typically in production environments, you don't enable APM because of cost issues as well as the resource issues. So this is a simpler way to just use the existing monitoring that you're doing without the APM and get closer to the diagnostic capabilities in the production environments. So using both logs and metrics, now you can get a much faster identification of the problem without manual intervention. Typically, when everything is going through, you don't need to get involved. Everything is stable, and you have the confidence that the production is going through. When you have to get involved when something is rolled back, it gives you much faster ability to diagnose and recover from your problems. So this is an example of how you would set up the templates. You can you can simply connect to your monitoring tool, pick up the metrics, and say, these are the ones that we would like to analyze as part of this rollout analysis. That's all I wanted to introduce today in terms of automated verification and how you can use it as part of the Argo. Mark or Cody, back to you. See if you have any comments, questions.
Thank you, Gopi. So why don't we're going to run a quick poll, Cody, if we can, while we do some Q&A. If you have questions about today's webinar, please enter them in the Q&A panel, and let's we're very interested in what kind of deployment tools you currently use. If you're using Argo, if you plan to use Argo, and if you're not using Argo, please tell us what you're using today, and you could tell us in the chat. And so with that, what I'd like to do is go over some questions. Please enter. We'll give it another 10 or 15 seconds for people to enter in the questions. One is coming up is Gopi. I already use Argo. How can I add this automated verification model to my existing Argo environment?
Oh, so if you're using Argo CD and you're not using Argo Rollouts yet, so you could add the Argo Rollouts, or if you're already using Argo Rollouts, it's simply a CRD that you'd apply with it. So you essentially modify your manifest and apply it with your Argo Rollouts, and the analysis service server itself is a separate system that's running outside your application. like the one that we have shown, and adding the manifest to your Argo rollout will enable your verification.
Oh, okay, great. How about Cody? How long do we keep the poll open? It'd be interesting to see the results if it's done. And we see, wow. So this is encouraging. Probably a lot of Kubernetes users out there, and it looks like what 76% either use it or plan to use it. What are your thoughts, Gopi? Is that what you've seen in the past?
That's the kind of usage that we are seeing. Argo CD is very popular. Argo Rollouts is also getting popular there. Yeah, this is kind of what we are seeing in the marketplace in general.
Do they have other projects? What other projects is Argo working on?
Argo also has Argo events, Argo workflows. The workflows is essentially a pipeline construction, a kind of a mechanism, but depends on running jobs in Kubernetes. There is a lot of work going on there in terms of scale and performance and RBAC. So Argo CD is the most simple for the developer-friendly system, and these other projects are also gaining a lot of traction.
Great. Hey, we've already mentioned this, but we had a question about our solution, OpsMX solution. Is it SaaS or on-prem? And as you can see in our Q&A panel, we have a trial, and it's a SaaS trial. Gopi, you talked about autopilot. Can you sort of tie that all together? And is it SaaS, on-prem? How's it offered up?
Yeah, so our platform is called ISD, Intelligent Software Delivery Platform. That it can be a SaaS platform as well as a on-prem. That has a bunch of these capabilities in terms of auditing and policy verification and application view with RBACs, things like that. And the biggest one is this automated verification of your deployments. So you can plug that in into your Argo rollouts or with Spinnaker or even Jenkins. So it can be both SaaS and on-prem.
Okay, and so that sort of flows into this other question. Does your verification model work with other platforms besides Argo?
Yes, it does. Yeah.
You just signed, you said Jenkins, Spinnaker are the main ones we currently support, right?
And with Argo rollouts, yes.
Yes. Okay. Super. Another question. It's and you mentioned blast radius. Can you sort of talk about sort of that concept and how do you manage the size of the blast radius?
So essentially, now the systems are fairly sophisticated in terms of application load balancers and ingress capabilities. But the idea here is that as we roll out the new version, how many people get affected with the new version. So for example, you have 10 instances running, and then you bring up one additional instance connect to the same load balancer, then less than 10% of the new users are using your new version. So for example, Netflix does this a lot. Also in that when they have a new update that's going to their customers, they would send it to the users who are using just the Firefox first. Mm-hmm. So then you can see the metrics and the performance, and you can do kind of A/B testing on it. So a similar thing applies to each one of these. So if we can control the traffic, we can specify the users coming from Firefox will be going to the new version, and everybody else currently uses the old version, or you can restrict only the 5% of any traffic at random goes to the new version, etc. So by doing that, you reduce the impact of the new version for you to be able to test it before applying it to the rest of the population.
So Netflix sacrifices the Firefox users first? I'll have to remember that.
No, just as an example.
Okay. How about, here's one. Can we validate the application deployments, like enforce some tags for the pods, etc.? Does that question make sense?
So that is a slightly different one. What we are saying is, so that goes with the policies. So can you specify some policy rules and then say any of the deployments that are going to my production must have certain tags? Yes. So what we talk about in terms of machine learning and statistical is different from being able to enforce the policies and policy rules. Yes, that's something that we support also, although it's different than automatic verification that we just talked about, but those are the policy rules. You can create policies that apply. So as you are deploying to the target environment as an admission control, you can ensure that there are certain policies that are followed by your manifest before they are accepted by the target.
Great. Okay, anything else? Any final comments? We really want to appreciate everybody's time today. I think it's a very interesting and critical topic. Cody, any final things? Back to you.
Well, Mark and Gopi, thank you both so much for joining us today. I'd like to quickly remind our audience that today's session was recorded. So following this webinar, you should receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So we do have those 4 $25 Amazon gift cards to give away. Our first winner is Jamil A. Our second winner is Shelby T. Our third winner is Nishal K. And our fourth and final winner is Daryl K. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim your gift card, but if you don't happen to see an email, please check your spam folder. I'd like to thank OpsMX for sponsoring today's webinar, and I'd also like to thank our audience for joining us today. We ask for just one extra moment of your time to fill out a brief post-webinar survey, but otherwise we hope to see you at an upcoming Techstrong Learning webinar or workshop. Everyone, have a great rest of your day. And Mark, Gopi, thank you much. Thank you so much one more time.
Thanks, everybody.
Thanks, everyone. Thanks for joining us today.